Good afternoon, one and all. This program is recorded and live streamed via YouTube channel of Christ College IJK. Welcome to RISMA 2021, Recent Innovations in Statistical Methods and Applications, International Webinar Series organized by the Department of Statistics in association with IQAC, Christ College Autonomous, Irinjalakuda, as a tribute to our retiring head of the department and Controller of Examinations, Dr. Davies Anthony Mundasheri. I kindly request all our distinguished participants to switch on your videos for a while. Now, it's a time to start something new and trust the magic of beginning. Let's begin with prayer.
കാരുണ്യ കൈവിളക്കായുള്ള ജ്യോതിസേ നേരായ മാർഗമേ കാട്ടണമേ ഇത്തിരി മുൻപോട്ടു പോകുവാനായെൻ്റെ ഉൾത്തിരിയൊന്നു കൊളുത്തണമേ സത്തായും ചിത്തായും സർവസ്വാത്മാവായും സത്യത്തിൻ തത്വമേ നീലസിപ്പൂ കാണായവയ്ക്കെല്ലാം കണ്ണിൽ പൊരുളായി കാണപ്പെടാതെ ഇരിക്കുവോനേ ഞാനൊരു മൺതരി മാത്രമാണെങ്കിലും നൂനമവീടുത്തെ സൃഷ്ടിയല്ലോ കൈവിടാതെ നീ കാരുണ്യ കാതലേ കൈവല്യദാതാവേ കൈത്തൊഴുന്നേൻ കൈത്തൊഴുന്നേൻ കൈത്തൊഴുന്നേൻ.
Now, I invite Dr. Sister Mariama, General Convener of this webinar, to introduce our first speaker of the day.
Good afternoon to all. It's my great pleasure to introduce our first speaker of the day, Dr. K.K. Jose, Honorable Director, School of Mathematics, Statistics and Data Analytics, Mahatma Gandhi University, who is reputed as very dedicated and enthusiastic teacher and outstanding research-oriented. Also, he was former principal and head of the Department of Statistics, St. Thomas College, Pala. His area of research is stochastic processes, distribution theory, time series modeling and analysis, multivariate statistical methods, queuing theory, etc. He has received many awards and honors like Best Principal of Ayashe Colleges in India, Sir Isaac Newton Award for Scientific Excellence, Best College Teacher Award at national level, and many more. He has 100+ research publications in credit, which include Communication in Statistics, Statistica, Journal of Applied Probability, Statistic and Probability Letters, etc. He published more than 15 books and has organized various national and international workshops and conferences. He has lifetime memberships in various academic bodies like the Indian Statistical Association, Indian Society for Medical Statistics, and so on. I am very much delighted to introduce him today to this webinar, even personally, as he was my research supervisor. I have learned much from his erudition, intellectual acumen, and his diverse qualities. He will talk to us on growth of statistics to data science and analytics. Dear sir, with warm welcome, may I now request you to take over this session.
Thank you, sister. So it's actually a very happy moment for me. So to have this invited talk. So this is actually in honor of Dr. Davis Anthony, who is going to retire from official service this year. So, respected principal, then Dr. Davis Andri Montessori, Dr. Sister Maria Makedi, experts from various areas, faculty members, statisticians, and my dear students. So this is a very recent subject that is actually what I want to just bring to you. So how statistics has developed into data science and data analytics. So that is actually it is a very simple general topic, but students should feel something about this, and certainly then only they will start studying or start loving statistics. So what statistics is and how statistics are developed to this much stage where everything is data driven. So come to the first slide. So sister, we can start with the first slide. So
yes, sir. Yes.
Growth of statistics to data science and analytics. Come to the next one. Next slide.
Yes, sir. Yes.
So I will start with this one. The modern era is a data-driven era. That is what I want to say. And decision makers and industries everywhere, all over the world, have realized the power and importance of data in making wise decisions. So in this talk, we discuss the attempts to measure uncertainty through probability and to gather information from data, which resulted in the development of statistics. And this led to statistical inference, statistical computing, as well as data analysis. Come to the next one. So statistics became a new technology for advancements in all disciplines, including biological and physical sciences, managerial and social sciences, engineering and health sciences, economic planning, business analytics, meteorology, and space sciences, and everywhere. So we cannot isolate any discipline which has not been influenced by statistics, which has not been affected by. So even in literature, we are making use of statistics. So in studies, in stylistic studies, and everywhere, we are making use of. So the modern problems are complex with big data and unstructured data, for which standard statistical techniques cannot be applied directly. So that is actually a challenge before us. So now we have big data. So earlier what we were having is actually data collected by statisticians, and that is actually structured or supervised data. Now we are having unstructured, unsupervised data, and that for that our statistical techniques in the standard sense cannot be applied directly. So this necessitated the need for data cleaning and transformation, data management, data mining, and data warehousing, then machine learning, deep learning, etc., using advanced computer programs. So next one. So from empirical and theoretical methods, we have transformed to computational and now data-driven methods for achieving data wisdom and decision making. So earlier, at the beginning of statistics, actually it was just data collection, or data was there. So all emperors, kings, administrators collected data. They were just having some information about things. And certainly statisticians developed theoretical methods that is actually developed different models, then analyzed them and so on. Then now, after some stage with the introduction of computers, we have data analysis, computation. So that is statistical computing. And now it has become data-driven methods. And that is actually what resulted into data science. this necessitates the use of not just statistics, not just mathematics, also appropriate theory and techniques in mathematics, statistics, computer science, domain knowledge, and information science. Thanks to advancements in computer science and information technology, data science and data analytics have evolved as powerful tools for decision making using statistical learning, modeling, and forecasting. So here I make a quick survey of developments which led to the emergence of data science and its applications. Next one. Next one. So in our life, we are always facing with randomness and uncertainty. So everyone, so even from a childhood, even an infant is having this type of randomness, the behavior, always there is uncertainty. So randomness means non-deterministic, lack of any systematic behavior, lack of any order, etc. And uncertainty means not sure, not predictable with the certainty. So we are uncertain about our future. Many of the students, they are always worried about their future. Many of the senior people, they are worried about their future. So they are nowadays, we are worried about COVID. So whether there is any chance for getting COVID or what is actually the probability for that and so on. So in very simple situations, so in the classroom example, so if you toss a die, so the outcome is random, we know. So there are different phases, 1, 2, 3, 4, 5, 6, but we cannot say what will happen in the next trial. So when this experiment of die tossing is conducted, so we cannot say what will happen in the next trial. So in inspecting an item from a production line, so we cannot say whether the item is going to be good or bad. So that is actually a random outcome. Next one. So always scientists were more concerned about quantifying uncertainty. So that is actually the probability. Chance can be expressed in terms of probability. Probability is a measure of uncertainty. It lies between 0 and 1. So these are actually simple things which you all know. So probability is a measure of uncertainty. So it is actually, so probability is meant for measuring uncertainty. So if the event is impossible, then probability is 0, we know. If the event is sure, the probability is 1. In between, it lies between 0 and 1. Next one. So there were different methods by which probability can be measured. And the earliest one, or the first attempt, was actually by Laplace, you can say. So that was actually due to Laplace. And that is actually referred to as the classical or the mathematical approach, which is the very simple one, which all of you might have studied. All students of statistics have studied in their undergraduate classes, even in the +2 level. So here we are having some assumptions. We are concerned with a random experiment where the outcomes are equally likely, mutually exclusive, and exhaustive. Then the definition is very simple. The probability of an event is defined as the number of favorable outcomes divided by the total number of possible outcomes. So that is actually always lying between 0 and 1. So, but what we have to remember is that it is based on these 3 assumptions. Equally likely means equal chance. Mutually exclusive means one cannot, only one will happen. So the occurrence of one will exclude the other one. The exhaustiveness actually implies, so we have to list all the possibilities. Suppose you are just concerned with the delivery, whether the newborn baby, maybe what is the probability that the newborn baby is a male or a female? Now, suppose you are concerned with the actual situation, there may be a transgender situation also. There may be some other situation also. So if you want to include such outcomes also, so certainly you have to list them. So it is not here. So the outcomes are not male and female. So along with that, you have to say transgender. So male, female, transgender, then any other. We have to consider that. Some abnormal cases also may be there. So if you are more realistic, that you have to, so suppose you are only considered with male and female, then certainly these are the exhaustive outcomes. Now suppose there is an outcome, so which is a transgender outcome, that we will be avoiding that. We will not be counting that as an outcome. That is at the clear. So this definition is a narrow-minded definition. This cannot be used always. So even in very simple situations, we cannot use this. That is why we come to the next one, that is the frequency approach. So in the frequency approach, there is no assumption at all. And it is actually due to von Mises definition or von Mises frequency approach. This gives a practical method which is statistical. So this is also known as statistical approach. And here it is actually based on repetitions or experience, what you can say. Here we repeat the experiment a number of times, say n times. Then we are counting the number of trials in which the particular event has happened. Then we are considering the relative frequency Ra equal to Na divided by n. And where Na, that is the number of times that particular event has happened, divided by n, that is the total number of trials of the experiment. Suppose you have 100 trials of the experiment, in which 10 times the particular event has happened, then the relative frequency is 10 divided by 100 or 0.1. Now suppose you increase that, then we will be getting a better approximate. So if you repeat the experiment very large number of times, then we will be getting a more accurate approximate value of PA. So here, PA is approximated by the relative frequency. So in order to get a good approximation, we want to repeat the experiment very large number of times. So here also we can see that the probability lies between 0 and 1. Actually, this actually received much criticism. So that is why the next definition or the next approach. So here we are just considering, so next one. So just a simple example. Next slide. So here I am just giving a data. So suppose you want to find the number of births, etc. So some deliveries, total number of births are taking place. So after 30, there were 19 boys, and the proportion is just 0.633. Then after 4 weeks, we counted the total number of births in the hospital, in a particular hospital. Then it is 116 births, out of which 68 were boys. And that resulted in a proportion or a relative frequency 0.586. Then you proceed. Then after 52 weeks, that is after a year, if you count the total number of births during that year, it was actually 1,237, of which 639 were boys. And then also we consider the relative frequency, that is 0.517. So what you can say is every day we are improving the probability. So with the larger number of repetitions, with the with a bigger number of repetitions, we are getting a more accurate probability, a more accurate relative frequency or relative frequency which is more close to the actual probability. So that is actually the way in which we are going on. So next one. So what is the theoretical basis for this? The theoretical basis for this is what you mean by the law of statistical relativity. This assures, this law states that in spite of the irregular behavior in individual trials, there will be a striking reality that the relative frequencies will converge to a fixed value, and that value is taken as the probability of the event. Suppose such a law of statistical relativity is not holding. Now, what we are having is what we are assured is by strong law of large numbers and weak law of large numbers that such a convergence will happen. So provided we are having very large number of trials, certainly that is actually assured by the strong law of large numbers. That is the law of statistical relativity, which is basically the basis of the probability, frequency definition of probability, has a theoretical background, a theoretical justification because of the laws of large numbers, and it is the basis of frequency approach. Now we come to the next one. That is like the axiomatic approach. So the even the frequency approach and the classical approach actually received much criticism from strong mathematicians. So then actually Ian Kolmogorov came forward. He was a Russian mathematician actually, so a Russian probabilist. In 1933, he introduced what is meant by the axiomatic approach based on measure theory. So this actually gives a mathematical foundation to probability theory or probability in terms of set functions. So here, so he considered a set function PA. It is a measure satisfying the axioms, 3 axioms. The first axiom is PA is always positive, is greater than or equal to 0. Probability of the sample space is equal to 1, or the probability of the null event that is equal to 0. The probability of the union of disjoint events is the sum of their probabilities. So all the students in your first year degree classes, you have studied all these things, you are studying all this. So based on these 3 axioms, we can develop the entire theory of probability. So that is actually full proof that is actually having very good foundations based on measure theory. So that is how Kolmogorov revolutionized statistics, or Kolmogorov revolutionized probability theory as having one with a sound mathematical basis. So now come to the next one. So now there is another approach also that is called subjective approach due to Reverend Thomas Bayes. He was a priest actually. So it is very commonly known as the Bayesian approach. So subjective approach means here from person to person it is changing. So it is actually using information from prior data, prior information or experience, and the information from sample data to compute posterior probability. So it is subjective and depends on personal experience. So just like an experienced doctor, so if you go to a new doctor, a very young doctor, then he may not be experienced. So if you go to a doctor having 30 or 40 years of experience, certainly such a person can detect your disease without any equipment. That is unexpected. So a very well-placed person can make a good judicious prediction about the probability for this, the chance for this, etc. So it may change from person to person. So that was actually something which received criticism. A more experienced person give more reliable prediction. With the modern computational facilities, this approach is now widely used. It is used in disease diagnosis, criminal investigation, everywhere actually. So the present era is that of Bayesian era. Now come to the next one. So subjective probability, it is an estimate that reflects a person's opinion or best guess about whether an outcome will occur. So it is actually very important in medicine. So it forms the basis of a physician's opinion based on information gained in the history and physical examination about whether a patient has a specific disease. So that is actually, so when you go for a medical consultation, so the prescriptions or the doctor's decision will be actually based on our previous history also. He may be asking whether your parents were suffering from diabetics, whether your parents have hypertension. So such questions may be there. That is actually to confirm his decision or confirm his conclusion. Actually, such estimate can be changed with the results of diagnostic procedures or more data. So if you have more test results, certainly there may be some further, some more correct decision or correct diagnosis, you can say. Now, next one. So, Reverend Thomas Bayes, so he actually lived only for 60 years, 1701 to 1761. So, when Bayes presented his theorem in the Royal Statistical Society of London in 1736, it was ridiculed. It received much criticism as utopian and impractical. So, it was ridiculed as impractical. It was criticized as utopian, something not realistic. But the whole mathematics was correct. So after 6 years of discussions, so he was awarded Fellow of the Royal Statistical Society. So his results were found correct, but it is not practical. That was the only criticism. His research findings were not at all considered much relevant. So they were rediscovered and published only in 1763, 3 years after his death. So 2 years after his death. But not used till 1960s. So till 1960s, this Bayesian approach was not there. But now, with the advancement of computing, data storage, now it is actually the era of Bayesian inference. Everywhere we are using Bayesian methods. Now come to the next one. Another method which is actually emerging importance nowadays, that is actually the fuzzy logic, due to fuzzy mathematics developed by Sathe, Lofty Sathe in 1966. In many of the mathematics classes, students are studying fuzzy logic or fuzzy mathematics. So fuzzy function measures the degree of vagueness. It also lies between 0 and 1. What is actually vagueness? So when you say there is light, say in the midnight, in the early morning there is light, by 6 a.m. there is light, by 6 p.m. also there is light, but 10 a.m. there is light, 12 noon there is light, afternoon 3 o'clock also there is light. So everywhere, so during from 6 a.m. to 6 p.m. the amount of light or the clarity of light is not the same. So during noon time, we know there will be more clarity or more light, intense light, whereas in the early morning the light may not be too much. So very mild like. So similarly, so when you say about rain, so it may be a mild rain, it may be a heavy rain, it may be a rain with storms. So we have to distinguish between these things. So when one student says he will pass the examination was easy. So how much easy it was? So that depends on the student. So if it was a very good student means a very top scoring student, then the teachers will believe him. Otherwise, suppose an average student says it was easy, the students may not have such a confidence. It's only that much. So complete vagueness is indicated by 0 and absence of vagueness is indicated by 1. It is an extension of a two-valued logic. It measures the degree of truth rather than true or false. So how much truth? So when you say tall, a person is tall. So it does not give you the exact, so whether he may be moderately tall, he may be very tall, high. So similarly, middle-aged person. Who is a middle-aged person? So whether the age is 50 or 60 or 70. So say super seniors. So that is actually, so they are of age more than 80. So what about a middle-aged person? So when you say rainy, when you say this tea is hot, so the degree of hotness also depends on the person who is drinking that tea. So suppose it is very hot for a young child, or say 1 year or 2 year child. So it is very hot. But for a person of age 50 or 60, it may not be so hot. So that actually depends. So there is actually some vagueness. So in order to measure that, so along with the measure of that, you have to give the probability. So it is like looking at an aeroplane. So when an aeroplane is in the sky, it is just like a point. Suppose you are going to the airport and you are close to the aeroplane, then certainly the actual picture is there. Otherwise, so it becomes clearer and clearer to reality as it comes closer and closer to us. So that is like the speciality. So that vagueness is also to be measured. That is like the next one, perceived probability. So next one, in this approach, along with the probability, one has in mind a measure of fuzziness also. It is not just a crisp probability. Crisp means actual probability. It may be a probability range. So probability 0.70 in fuzzy probability means something between 0.6 and 0.8 or 0.65 and 0.75. So something, some range is there. Fuzzy probability gives a range. It depends on the degree of truth based on data. It will differentiate between the levels of truth. Now come to the next slide. So what is the difference between fuzzy probability and crisp probability? Suppose you are tossing a die. What is the probability that it will show 6? Certainly it is 1/6. It is a crisp probability. It is actual value. It cannot change. This is a crisp probability. All credible mathematicians will agree on this exact number. So the probability that a fair die will show the phase 6 is always 1/6. But suppose a meteorologist forecast the probability of rain tomorrow is 0.70 or 70%. Does not mean that it will happen with exact probability 0.7. So what actually is assured is actually it is something which is more probable. Using the same weather data, another meteorologist will typically announce a different probability. Another person may say it is 72%. Another person may say it is 65%. Another person may say it is 75%. So what is the difference? The difference is it just gives a range. It gives just an idea. Suppose he says the probability is 70% or 20%. 20% means a very low, very low chance. Suppose he says it is 90% or 0.9, we say very high chance. So 0.99, so we say it is almost sure. So it depends on the strength of the data. So along with the fuzzy probability or along with the probability, there should be something, some measure of fuzziness or some measure of vagueness. That is actually fuzzy theorists, fuzzy mathematicians are advocating, and that is actually called the fuzzy probability. And the entire theory of probability is being rewritten in terms of fuzzy probability nowadays. Now come to the next slide. So these are actually some methods by which probability can be measured. These are many of the methods which are commonly used. Now you are coming to conditional probability. Conditional probability is also something which gives you probability based on some additional information. Probability of A given that the event B has happened. This is actually based in Bayesian approach. Bayesian approach is actually based on conditional probability. And he utilizes what is called prior information. So probability of rain in Kerala during July. Suppose you are given the information that it is July 15, then certainly you will say there is high probability. Suppose you are given it is February 25th, then you say the probability is very less. So that is actually along with this condition, you can make a more reliable prediction of the probability, more reliable statement of the probability. Next one. So now I will be coming to the formal statistics. So what is statistics actually? So actually probability theory is behind statistics. So probability theory gives some basis for statistics. So what is statistics? It is a body of methods for making wide decisions in the face of uncertainty based on systematically collected data and calculated risk. And for that, we develop statistical methods. So for the primary purpose is actually for making wide decisions. Why? Because of uncertainty. And for that, we are making use of probability. And that is usually based on systematically collected data. And calculated risk also you will be giving in terms of probability, the significance level, the power, the probability of type 1 error, probability of type 2 error, etc. These are actually calculated risk values. And what is a statistical data? It is an aggregate of facts collected according to a well-planned procedure with reasonable standards of accuracy and precision and placed in relation to one another. And statistical data, that is the raw material for a statistician. So these are actually what you have studied in your graduate classes. Now, what is actually the reality? The reality is nowadays we are getting data from everywhere and they are not systematically collected. So that is actually, so I will come to that in coming slides. Next one. So what are models? So everywhere we are trying to model. So science does not deal with reality, but with the models of reality in physics or chemistry. So you have studied different models. So why? So we are not just concerned with the reality, what we are. So in many cases, reality is not fully known to us. We are trying to unravel the truth. So what is the dynamism behind that? So scientific study is to search for better models of reality. A model is a description of reality, but models are not equal to reality. Usually, a simplification helps to understand reality. So a model is simply a simplified presentation of the reality, and it helps to understand reality. And a famous statistician, Dept Box says all models are wrong, but some are useful. So models are useful like a torch. Now the suitability and complexity of models can depend on the purpose, the understanding, the prediction. It is good when it is close to reality. So all models are useful. That is actually what we can conclude. Now come to the next one. So these are actually some models you have studied in physics, chemistry, economics, etc. The ideal gas equation, then the demand law in economics, consumption function, then production function, the regression equation, that is the relation between age and height. So all these are actually models. So what is the speciality? So there are actually some parameters, etc., some unknown things, etc. Some are known things. So PV equal to RT, this R, that is a parameter. So that is the universal constant, you know. So that way everywhere. So next one. So some people say anything can be modeled, or some people say my research is very complex. I am doing a very research on a very complex subject. So I cannot be described in terms of any model. Next one. So the thoughts about how a system works produce a model. So what I want to say, everything can be modeled, but the model may not be a good one. So the thoughts about how a system works produce a good model. So how intensively you are studying these things. So how intensively you have gone to deep into the subject, certainly you can produce a good model. So in science, mathematics is a common language used to express these thoughts. So by mathematics, what I mean, some equations, some variables, some parameters, etc. are used for developing a model. So actually in mathematical terms, mathematical equations should be given. So using variables and parameters. Now come to the next one. So in statistics, so we are studying about probability models. So binomial distribution is a probability model for dichotomous phi. Poisson distribution is a probability model for arrival. Exponential distribution is a model for lifetimes reliability. Then normal distribution is a model which can be used for almost all types of data. Log normal distribution is a model for income and wealth. So that way we have some standard models. But in reality, so you have to develop new models. That is actually the problem in research. Come to the next one. There are two types of models. One is deterministic, which is something like a mathematical equation, whereas another is actually a stochastic model, where you are having some error component, some random component. So in a deterministic model, there is no randomness, and the outcome is totally predictable. Usually, mathematicians believe that some events or something which is some phenomenon in nature are mathematical, exactly mathematical. But statisticians proved out that there is randomness. There is randomness. So suppose you are concerned about a linear model, say a linear relationship between price and demand. This can be given as yi equal to a plus bxi. Certainly that is true, but we know there may be fluctuations. So that is actually the original value may not be, so all points may not lie on a straight line. That is actually what you can observe. So this may be the true situation. One more click. This may be the true situation. So it may fluctuate from the other one. One more click. That way, that may be the true situations, but you can model in terms of a straight line. One more. So then you are having another stochastic model. So in stochastic sense, a statistician will be using this model. Y equal to a plus bxi plus epsilon I, where epsilon i's are normally distributed. So independent and identically distributed with the mean zero and variance sigma square. So in the least square theory also, curve fitting also, many of you have studied this. So there also you are bringing a random component. So yi equal to a plus bxi plus epsilon I usually referred to as the error term or the random component or the stochastic term. So that actually gives you a stochastic model. So a stochastic model will involve a random component also. Next one more. So statistical inference based on data is actually something like reverse engineering. So going back, we are actually predicting. So from the data, you are developing a model, then you are using that model to predict. So that is actually reverse engineering. So based on stochastic models, we are trying to quantify the role of chance. Any stochastic model can, in principle, be confronted with the data. So it is actually need to be validated using data, and then only it can be used. So if the validation results in an abnormality, then we cannot use that model. So always, so we have to be very clear. That is actually the problems in the stochastic model or problems in stochastic model. Then come to the next slide. So now empirical modeling or data-driven modeling. So it is actually based on, or it is actually an application of statistical techniques. It is based on past data. It is probabilistic in nature, and what we can say, the projections or forecasts, etc., are short-term only. So we cannot forecast the price for gold for the next 10 years. It can't be realistic. Even though we can forecast, it will be true for just 1 month or just 1 week. Similarly, we cannot forecast the number of persons who will die because of COVID for the next 10 years. It will not be a realistic one. So we can just forecast for 1 month maximum. Even then, there may be fluctuations. So you can just forecast for just 1 or 2 days or for 5 days or 1 week. Then there may be some slight changes. So remember, so in statistical modeling, and we cannot forecast for a long term. Only short-term predictions are possible. And this is the limitation. It requires reliable and representative data. If the data is not an adequately good one, our predictions will be wrong. And only probability for occurrence can be given. So we cannot say it will happen with the surety. So we can say with the 0.95% or 95% confidence limits, 99% confidence limits, etc. So that way, only the probability for its occurrence, probability for its validity can be given. We cannot say anything with the surety. Now I am coming to another next slide. So model development steps. So suppose you want to develop a model, there are usually 7 to 10 steps. And firstly, you have to identify the problem. Then you have to conduct the review of literature and identify the gaps. Then formulation of the hypothesis and collection of data. After collecting the data, you will be developing a mathematical or a statistical model, and you will be solving that, and you will be finding a solution. Then you have to interpret it. You have to check whether it is valid one, whether it is compatible with the compatible with the assumptions, with the biological assumptions, with the actual assumptions. So comparison with observed values, then the model is validated. If there is no agreement, you have to go back. So you have to modify your assumptions, you have to modify the problem and so on. So if it is in agreement with the reality, then you can start report writing, then you can make presentations, then you can send it for publications and so on. That is how a model is developed. So usually 7 steps, or you can say up to 10 steps. So that is actually what is done in a model development. Next one. Now I am just concerned with modeling in epidemiology. So now presently we are always concerned. So all of us are concerned with COVID modeling. So what is this? So the study of the distribution, the frequency and the determinants of health problems and disease in human population. That is the definition. So all those things you have to define very clearly. Then what is the purpose? To obtain, interpret and use health information to promote health and reduce disease incidence and its impact. That is the purpose for modeling dynamics of COVID-19, for developing a model for AIDS, for modeling model for SARS, so for model for Nipah. So actually to interpret and use health information to promote health and reduce disease incidence and its impact. Next slide. So in any modeling situation, so suppose it is in health, you have all these problems. What is the health problem? The disease or condition, its manifestation, characteristics. Then who is affected? Whether there is any dependence on age, sex, social status, ethnic group, etc. Where does the problem occur in relation to place of residence? Whether it is in rural places or in urban places or in cities or metropolitan cities, etc. Then when does it happen in terms of days? Whether it is during rainy season or hot season, whether it is whether there is any such seasonality. How does the disease occur? What is the condition? What are the sources of infection? What are the reasons? What are the susceptible groups? Whether old-aged people or young people or males or females, etc. All those things. So you have to get data on all such things. That means you have to collect data on a very large number of characteristics. Now come to the next one. So the general dynamics of an epidemic. So actually how the epidemic spreads, it will pass from one class to another with the passage of time. Then a mathematical model or a statistical model tries to capture this flow by using compartments and predetermined variables, which are usually deterministic. A statistical model will incorporate random components and factors along with deterministic components. Next slide. So the basic so this is actually for COVID modeling. So basic reproductive ratio, how much, whether an infection can occur, that determines, that is actually something which is depending on the basic reproductive ratio, the growth rate of infection, asymptomatic period. So usually for COVID, it is usually assumed to be 14 days. So during 14 days, if you keep the patient away, then certainly it will not spread. Necessary effort to control. So all those things are usually depending on the basic reproductive ratio. So that way you can find some crucial parameters. Now come to the next slide. So just click on. Click. One more. So now you can see. So from one person, it actually transmits to 2 persons. From that 2, it goes to 2. Here the reproductive ratio rate is actually R0 is equal to 2. So transmission. So from 1 person to 2, from 2 persons to 4, and so on. Some geometric progression. Next one. That also you click. So here the basic reproductive ratio is 1.5. Then from 1 person it goes to 1 person or 2 persons. From 1 person to 1 or 2 persons actually. So that way, so that is how it is actually, that is why it is becoming 1 or 2. So it may be either 1 or 2, or the average is actually 1.5. So in that case, the growth is not so speedy as in the case of R0 equal to 2. So in the case of COVID, it is 4 or more. So in the early stages in Kerala, it was actually just less than 1. Nowadays, it is actually nearing 6 or 7, or some days it was 10 also. So that is how this picture. Now come to the next one. So what you do is, so you will be considering all this and you will be developing a model. So in the COVID case, we are trying to make it flatten, or we are trying to make it down. So the curve is coming down at the point A, then at the point B, at the point C, and so on. So this is how the model is developed, and from that we are drawing conclusions. So this is actually what is done in a model building situation. In the case of COVID modeling, this is how people have developed, or scientists have developed the models. Now we will be coming to the next one. So correlation and regression. So all these things, suppose you are having a bivariate data. So our study is not confined to just one variable. So in many cases, we have to consider two or more variables. If there are two variables, then you want to find the degree of relationship between the variables. Measure that, we will be making use of correlation coefficient. Otherwise, suppose you want to find the actual linear relationship between the two variables, then you will be using regression. So when we are having more variables, more than one or two variables, then we can use partial correlation, multiple correlation, multiple regression, etc. So certainly there is nonlinear regression, polynomial regression, logistic regression. So all these are actually problems in data science, actually regression theory. So for forecasting, for prediction, etc. So now come to the next one. Our study is not confined with just one random variable. So in statistics, we have stochastic processes. So for your MSc courses, you are studying stochastic processes. It is actually concerned with a family of random variables. So these are actually some standard models, random walk processes, Markov processes, Poisson processes, etc. I'm not going to the deep. So all of you know. So the senior people know. Certainly students, you have to study these things in detail in coming years. Come to the next slide. There is another one that is actually the birth and death process. Birth and death process. This actually generalizes most of the situations. Birth and death processes can be applied in banking. So in queuing. So queuing, when you are part of a queue, when a new person arrives, it is like a birth. When a new person leaves the queue after getting service, it is like a death as far as the queue is concerned. In the case of banking, suppose you are opening an account, it is like a birth as far as the manager is concerned. Suppose you are closing the account, then it is like a death. Similarly, remittances and withdrawals. If you are remitting some money to your account, then it is like a birth. When you are taking money, that is withdrawals are taking place, it is like death. Input, output in computer operations. So you are giving the input and the computer is doing the work and you are getting the output. There also birth and death is taking place. Disease growth. So people are getting disease and after treatment, the number of persons affected by the disease reduces. So day by day, people are getting COVID. Then some persons are getting relieved. Then some persons, new persons join. Then there is a birth. When one person, not me, except death, one person is relieved, one person is recovered from that disease, it is like a death. So traffic problems also, the same situation you can have. So birth and death process is a common model for most of the situations, many of the situations like input, output. Now come to the next one. There are birth and death process of emigration. So as far as Kerala people are concerned, so many people have gone to these Middle East countries, to Saudi, Dubai, and so on. That is actually immigration. So there are many people who have come from Assam, so from other states. So that is actually immigration. So suppose you want to accommodate that, then you are having the rate as the birth rate as n lambda plus c and the death rate as n mu plus k. So only some modifications to the birth and death process is needed. Some slight modifications are needed, and that you will be studying in detail later. Now come to the next one. In stochastic modeling, you are having some standard processes called Brownian motion processes, branching processes, compound models, epidemic models, insurance models, risk models, renewal counting processes, time series models, RISMA models, box Diggins models, etc. These are standard models. So I am not discussing in details. Now come to the next one. Another is actually lady testing the T screen. Now it is actually 2:30 or more. So it is time for tea actually. So there was actually some such problem during 1920s in the University College London. So there actually they have a custom of afternoon tea party in the university or in the department. The faculty members sit together and take tea. So and one lady was there. So you have seen that picture. So there a lady sitting in the middle. She is actually making a claim So I can tell whether the milk is poured first to tea or the tea is added to the milk. So many of you have prepared tea. So can you say by tasting a cup of tea whether tea is added to milk or milk is added to tea? This was the problem. And that lady was saying I can say correctly. And R.A. Fisher was there. Next one. Fisher was there. So Fisher means Bernard Albert Fisher, R.A. Fisher, the father of modern statistics. And he is the most influential statistician. So he was there. So I will come to that. He is the person who introduced randomization, variance, null hypothesis, maximal likelihood theory, and so on. And he is actually to be remembered as a person, who has single-handedly created the foundations of modern statistics. Now come to the next slide. So what the lady was just thinking was actually, she will just say whether it is correctly or not. So suppose there is only 1 cup of tea, the chance for a correct guess is 50%. So if there are 2 cups, certainly the probability becomes 0 with the 0.25, 1 cup each out of 2, 50% each. So suppose she says both the cups are tea added first, it's only 25%. Both cups are milk added first, it's only 25%. 1/4, 1/2 into 1/2. So that is actually what she thought, what Fisher did. That is the next one. Next one. So Fisher proposed 8 cups of tea. So half with tea first and half with milk first. And he presented it in a random order. So at the bottom, he had indicated that. And he brought it, and the lady tasted them and made her decision. And actually, this led to a revolutionary change in statistics, actually. So that lady's question or that lady's challenge led to the development of design of experiments. So which is actually the basis of all experiments not only in statistics, everywhere actually. So this actually led to the principles of randomization and replication. Randomization means, so you have to randomly allot. So the COVID medicine is the clinical trials, it is randomly allotted. Then replication, not just for one person. So you have to apply it for a number of persons. It needs to be repeated. So all these principles were brought in with this experiment or with this situation, and that actually led to the development of design of experiments. Now come to the next slide. So what I want to say is just one incident. So Fisher actually developed it into a theory, and he thought on it, and he worked on it, and he developed the design of experiments. That is how scientific inquiry or scientific research is going on. So just one point, just one fire, that will ignite things. So now come to statistical inference. These developments led to statistical inference like estimation of parameters, testing of hypotheses, similar things, multivariate analysis, then discriminant analysis, classification methods, pattern recognition, cluster analysis, principal components, canonical correlations, factor analysis. All these are actually what you study in your MSc classes, but all these actually were developed after these type of events. And statistics in the new era, next one. So in the new era, the present era, the raw material of a statistician is data, that I have already said. But the present era is of quality and big data. So everywhere we are looking for quality. Everywhere we are confronted with big data. It is not systematic structure, but it contains information. So every data, the data in your mobile, that contains information. That contains information regarding your preferences, your tastes, your likeness. So whatever things you like. So just I will, suppose I go through your mobile, certainly the photos you have stored. So your emails, your WhatsApp group, the Facebook postings, etc. will give me some idea about your nature or your interest, your like. So for that, actually, everywhere data is warehoused, data is collected and stored. That is data warehousing. Then from that, you have to take it. So that is actually data mining. Computer programs are needed for speedy delivery. So since you are having enormously big data, so for that, you have to make use of computer programs. Data quality is very important. So for that, actually, data cleaning or pre-processing methods are very essential. So that is how we are coming to the next one. So now, so in the very recent issue of Technometrics, there's a big data. So last year, 2016. So big data, more challenges. So there it was actually a full issue of Technometrics published by American Statistical Association. Now come to the next one. So this is actually a paper which was published in 2015. So this actually gives some idea about the development of data science, and that is actually something from biostatistics. So accurate estimation of influenza epidemics using Google search data. So using this web data, they were developing some models for estimation of influenza epidemics. So for that, actually, they've developed time series models. They made use of these data sets, and they developed what is meant by the present day data science. Or these things were actually behind that, or they developed some techniques by which big data can be analyzed. So they found that the present day the statistical techniques were not adequate. Next one. So what is data science? The term data science was appeared in 1974 in a book called Concise Survey of Computer Methods. So in that book, Peter North was a famous computer scientist. He defines data science as science of dealing with the data. So what he means is dealing means all types of cleaning, processing, storing, and manipulating of data that happens before the data is analyzed. So in many cases, you have to transform, you have to make use of transformations in the data, you have to make use of averaging in the data, you may taking ratios, just like index numbers, PT, price relatives, PT by PT minus 1, some such operations you have to do. All these are actually what we mean by dealing. Some appropriate transformations, appropriate methods, techniques. So only after that you can make proper statistical analysis. Only after that the data will be of good quality. That is actually the arrival of the personal computer revolutionized access to data and our ability to manipulate data. It can be argued that data science is simply a response to this new technology. Now come to the next slide. So usually people say a data scientist is a statistician who lives in San Francisco. San Francisco, that is actually the capital of software industry. What types of software programs are being developed in US San Francisco? And data science is statistics on a machine, on a computer, on a laptop. A data scientist is someone who is better at statistics than any software engineer. And he should be better at software engineering than any statistician. So it is not statistics, it is not engineering. It is actually a combination of that. You should be an expert in statistics as well as software engineering. Next one. Several factors prompted these innovations. First, people needed to work with data sets which we now call big data, that are larger than pre-computational statistics would have imagined. Second, industry focused on making predictions about market trends and customer behavior and more for commercial uses. The inventors of data science borrowed from statistics, machine learning, and database management to create a whole new set of tools for those working with the data. Statistics, on the other hand, has to change significantly in response to the new technology. The field continues to emphasize theory than statistical computing and deep learning of data. I am just criticizing the present day or the former, the past day statisticians also. So many people are criticizing that. So we have to develop more. And now come to the next slide. So now data science and data analytics is widely used in medicine for transforming healthcare treatment, etc. So find out how Intel and Oregon Health and Science University is working on DNA structures analysis. So even for cancer treatment, you can have doctors from different continents. So one doctor sitting in Tokyo, one doctor sitting in New Delhi, one doctor sitting in UK, one doctor sitting in New York. So they are consulting. So that is possible through data science and data analytics. So for that, actually, you can make use of communication systems. So you can analyze, you can see, you can discuss. All these things are possible with the data science and data analytics. Changing the future of heart health with data science and data analytics. Similar is the case with other situations. So heart failure and transplantation program are making primitive heart health a reality with the predictive analytics. Predictive analytics, that is actually a specialty in data analytics. Next one. So now, we have realized that data is powerful, or data are powerful and valuable. So there are different data mining techniques, which are actually cluster analysis, for example, cluster analysis, regression analysis, remote sensing, pattern recognition, classification, discriminant analysis, principal component analysis, canonical correlation analysis, factor analysis, correspondence analysis. These are actually some of the topics which we study in multivariate analysis. So most of the MSc students, MSc statistics students have studied these things. So data scientists are actually data science or data analytics persons are using these things, certainly with the help of some computer programs also, only that much. So come to the next slide. This gives how statisticians can use data mining techniques or data analytics techniques to study about gene sequences, DNA structure. So nowadays we are having the genome structure, so the Human Genome Project, etc. So they are actually analyzing these to reduce disease and improve medicine. So some genetical corrections, etc. So this is actually the genetical corrections, how so we can reduce disease. So that is also some change in the order in which the DNA structure is there. So that is either thing. So next one. So suppose you want to paint your house. So for that, you need not go to the paint company. So you can just visit their website and you can just quote the number. So just like textile industry, suppose so optimizing business decision making with predictive analytics, discover how nip and paint is improving, and so on. So now on the next slide. So statistics is used by sports people also to develop strategies, etc. Next slide. So that is actually policy formulation, that is social media. So you are making use of Facebook's, WhatsApp's, etc. to influence people. That is how politicians are influencing people. Next one. Artificial intelligence, speech recognition, etc. In industry, they are making use of this. Machine learning, etc. Next one. So financial institutions, industry, etc. are making use of statistics to develop things for increasing quality and other things. Next one. So using statistics, you can search for natural resources where there is petroleum, where there is, so suppose in the space expeditions, so whether there is water in the Mars, where there is water in the moon, and so on. So in all such, you can make use of these things. So whether there is gold somewhere. So for that, actually, you can make use of statistics. Now come to the next one. So thus, statistics is used in a very wide range of areas like data science, data analytics, biostatistics, epidemiology, market research, business analytics, actuarial science, insurance, management decision making, disease mapping, health diagnostics, space research, remote sensing, statistical physics, journalism, advertising, sports, forensic science, communications and public relations, policy decisions, genomics, microarray analysis, etc. Next one. So in the present era, we always hear about, so just click, we always hear about big data, data science, data analytics, data mining, data warehousing, artificial intelligence, machine learning, deep learning, etc. Is data science and analytics the new brand name for statistics? Next slide will give you the answer. Next one. Data wisdom is a rebranding of all aspects of applied statistics. Advancements in computational statistics as revolutionized statistical thinking. It has become the backbone of data science. So it is actually data analysis or computational statistics. That has come to the next one. So we can redefine statistics as the science of learning from data. It helps to make wise decisions in the face of uncertainty using data and calculated risk. And new challenges are there because of big data. Come to the next one. In 2015, the president of the Royal Statistical Society, in the meeting of the annual general body meeting, he presented a paper called Statistics as a Data Science of the 21st Century. So there actually he was predicting the importance of statistics, and this actually became reality now in 2020 or 2016, 17 and so on. Next one. So even though we say data science is of recent origin, it has been there for the last 50 years. So people say from 1962 onwards, data science was there. So data science was developed by biostatisticians during the 1960s. So now come to the next slide. So we are coming to the conclusions. So what is data science? Data science is an interdisciplinary field that uses scientific methods, processes, algorithms, and systems to extract knowledge and insights from many structured and unstructured data. Data science is related to data mining, machine learning, and big data. It is an emerging discipline to unify statistics, data analysis, machine learning, domain knowledge, and their related methods in order to understand the data for deep learning. So it is actually an emerging discipline, not yet fully developed. Next slide. So it is referred to as the fourth paradigm. It uses techniques and theories drawn from many fields within the context of mathematics, statistics, computer science, domain knowledge, and information science. Some philosopher computer scientists say it's the fourth paradigm. So we started with empirical, then theoretical, then computational, and now we have come to the data-driven world. He asserts that everything about science is changing because of the impact of information technology and the data deluge. Data has become very powerful, and the whole world is now data-driven. Next slide. So in data science, more important is data quality. So we are more concerned with the quality of the data for that cleaning, transformation, etc. The extraction, transformation, and loading. So here data may be supervised or unsupervised. So unsupervised means those data we are getting from social media, from mobiles, from emails, etc. So now come to the next slide. So next one. Typical architecture. So how the data quality can be ensured? For that, data extraction is there, data transformation is there. So human knowledge may be made use of, metadata may be made use of, data analysis may be made use of. Then human knowledge, schema integration, dictionaries, everything is done. And after that, we have obtained quality data, then data loading. And that is actually what data scientists are doing. But data analytics comes after that. Data analytics is statistician's job. It is after data science. It is after making the data of good quality. So come to the conclusion. Next slide. So we conclude as follows. Statistics is the study of collection, presentation, and organization of data, computing and analysis, inference and interpretation for making wise decisions using supervised data. Whereas information science is an interdisciplinary field primarily concerned with the analysis, collection, classification, manipulation, storage, retrieval, movement, dissemination, and protection of information. Now coming to data science is the extraction of knowledge from data. It employs techniques and theories drawn from many fields within the broad areas of mathematics, statistics, computer science, information technology, then statistics, and so on. So we are actually more concerned about the ways in which we can extract knowledge from data. We can extract information from data. Now come to the last slide. Data is powerful. It's a data-driven era. Come to the next one. So we ensure quality of data. That is actually what data scientists are doing. Then they are drawing conclusions, or they are drawing information using statistical techniques. So better data, better results. That was the slogan by United Nations for the International Statistics Day. So remember, quality of data is more important. So students should always feel, so honesty, you should be honest in collecting data. You should be honest in using data. So that is actually what is important. So better data will ensure better lives of human beings. So thank you.
Thank you, sir. Thank you, sir, for your valuable insights. The meeting is now open for sharing. Dear participants, if you have any queries, you may ask now.
I have crossed the time bound, I think.
Sir, it's okay, sir, no problem.
So from 5 minutes more.
Okay, sir.
So these are simple things. So if anybody want to ask, they can email also. Students.
Dear participants, if you have any queries, you may ask now. Hope there is no queries.
So you can go to the next session actually. So
yes, sir. I invite.
So I thank Dr. Montessori, that is Davis, then Sister Josephine, and all of the members in the department in the college for organizing this program. I wish you all the best.
Thank you, sir. Thank you. Now I invite Ms. Arya Damodaran, Research Scholar, University of Calicut, to deliver vote of thanks. Over to you, Arya.
Hello, am I audible?
Yes, yes.
Good afternoon, one and all. It's my privilege to have been asked to propose a vote of thanks here. And Joseph did a wonderful presentation on the growth of statistics with the data science and analytics. It was really informative, and it will be very, very useful for the students and the research scholars. Now, on behalf of the organizing committee and all the participants, I extend a very hearty thanks to Speaker Dr. Kiki Jose, Honorable Director, School of Mathematics, Statistics and Data Analytics in Mahatma Gandhi University, who spent the valuable time from his busiest schedule for us. Thank you, Joseph.
Thank you.
Thank you all.
Thank you.
Thank you, Arya. I kindly request all the participants to switch on your videos for a while. Now we are moving on to our next section. I now call upon Ms. Megha CM, coordinator of this webinar, to introduce our second speaker of the day. Over to you, ma'am.
Thank you, Kigo. Am I audible? Good afternoon to all. It's my privilege to introduce our second speaker of the day, a very devoted and passionate teacher and researcher, Dr. C. Satheeshkumar, Professor and Head, Department of Statistics, University of Kerala. Presently, he is the President of Kerala Statistical Association. He is permanent reviewer of Mathematical Reviews USA and also editorial board member of International Journals of Statistical Distributions and Journal of Statistics and Mathematical Engineering, and many more. His area of research is distribution theory, multivariate analysis, climatology, marketing research, etc. He has more than 100 research papers in his credit. He is referee to more than 25 international level referee journals of high reputation in statistics. He organized more than 20 international and national conferences, seminars, workshops, and other training programs, and also coordinated several refresher courses in statistics and research methodology. Today, he will deliver the talk on Poisson related distributions. On behalf of RISMA 2021, I welcome you, dear sir, to lead this session. Welcome, sir.
Thank you, Megha. Thank you so much for your nice introduction. Hello, I hope you can hear.
Thank you, sir.
Okay, it's audible?
Yes, sir. Yes, sir. Yes, sir.
Shall I continue?
Yes, sir.
Once again, I utilize this occasion to thank Megha for introducing me nicely, and the organizers of this conference to give an opportunity for me to address you with some of my humble research. Especially, I'm very much happy to be here with this gathering, mainly because this is in fact to honor our beloved professor, Dr. Davis Anthony. Davis sir, he is my as a brotherly, my loving brother, in fact. Also, my sister is there. She is coordinating this conference. With your blessings, let me to directly jump to the topic of the conference, the talk. In fact, this talk is mainly targeting the students. I'm sure that several postgraduate students in the college also attending this conference, and as well as researchers. So let me to start from the very beginning, very simple but very important idea. All of us know very basically from the degree class onwards, we study the Poisson distribution. Yeah, isn't it? All of you aware of Poisson distribution, and it's important. It is one of the most important distribution among the discontinuous distributions or discrete distributions. It enjoys a similar role with respect to the to discrete distributions to that of the normal distribution among the class of all absolutely continuous distributions. So that every student may, and I hope they can enjoy, or they can, it is digestible thing to talk about Poisson distribution and its further developments. In fact, while we considering the Poisson distribution, what is the main drawback of this distribution? In fact, you know, the mean and variance are equal in case of Poisson distribution. This, if you consider a Poisson distribution with the parameter lambda, then mean is lambda and variance is again lambda. So they are the equidispersed. So this distribution is an equidispersed distribution. Even though this is an interesting property of the Poisson distribution, but practically, while all of us know, when we go through practical situations, it is difficult to find such situations of equal mean and variance. So the problem, while we considering the rare event situations, you have to model rare events. There the Poisson distribution has relevance. But while coming through or while tackling some practical problems, this equidispersion is a demerit of that distribution. So what we do, how to overcome this demerit? In fact, long back itself, several scientists in the area worked on that. Among them, Badwell and Crow in 1964, they introduced a class of distributions, namely the hyperpoisson distribution. This is the origin of the hyperpoisson distribution. Yeah, in fact, you can think of the details of the Poisson distribution. You can go through these several books. Most of the statistical books contains details about Poisson. Even then, mostly you can, it's a reference level or research level reference. You can think of Johnson, Kemp and Coates book on discrete distributions. And in 2005 edition is there, latest. And Hayes' book is there in 1964. And 1967, yeah, 67. And this Poisson distribution, due to its simplicity and as well as the practical relevance, it is applicable in several areas for modeling rare events that occur in, say, occur with respect to time, area, region, volume, or space, and consequently, it's applicable in areas like actuarial science, agriculture, biosciences, commerce, demography, operational research, management, medicine, engineering, genetics, social sciences, etc., etc. Almost several areas you can come across this in queuing theory, etc. This relevance of the Poisson distribution is remarkable. In fact, this equidispersion of the Poisson distribution, or the property of equidispersion of the Poisson distribution, is found to be inappropriate what I mentioned earlier, it is found to be inappropriate in several practical situations. To overcome this demerit, the Poisson distribution has been generalized in various directions. I mentioned among them, important among them is the Bardwell and Cross 1964 works. They introduced this hyperpoisson. My talk concentrates on this hyperpoisson and some related results, related distributions. In fact, we have developed several works or several distributions in this connection. I shall give some of them for your understanding and for your to motivate you to such areas or applications, so you can utilize those works for the application side. So that is the important, the relevance is there. These in rare event situations, even this hyperpoisson itself is not adequate or not gives good fit. But a model near to hyperpoisson or Poisson will be more suitable. So that is why we think of alternative versions of the hyperpoisson distribution, or its generalized versions of hyperpoisson distribution, etc. Okay, let me to share my slides. Okay. Okay, first of all, we are just to give some simple aspects of hyperpoisson. Then the alternative hyperpoisson. Thereafter, we think of how to estimate the parameters of the alternative hyperpoisson and how to test the significance of the parameters. Thereafter, we think of the more generalized situation, alpha generalized hyperpoisson distribution, and its estimation and testing aspects. And thereafter, the alpha generalized Poisson distribution of order K is a most generalized situation, and some references for your understanding and your further study. This is the skeleton of my talk. First of all, I mentioned earlier, once again, Bardwell and Crow introduced the hyperpoisson distribution through the probability mass function G1 of x. The probability mass function of the hyperpoisson distribution is relatively simple, like Poisson. This is the probability that x equal to small x equal to gamma lambda divided by gamma lambda plus x, theta raised to x divided by phi 1 lambda theta. This phi 1 lambda theta or phi AB theta is the confluent hypergeometric function. In fact, I have not mentioned here the details regarding confluence hypergeometric function, but in the due course, in the talk, we need it. It's there. It is an infinite series. Phi AB theta is an infinite series, summation say r equal to 0 to infinity, AR divided by BR, theta raised to r by r factorial, where AR is the Pockhammer symbol, A within bracket r means A into A plus 1 into etc. A plus r minus 1, and BR is B into B plus 1 into etc. B plus r minus 1. So here phi 1 lambda like that, so that it also can be represented in AR. It can be represented gamma A plus r by gamma A like that. We can also represent it in terms of gamma function. So here we denoted the gamma function and the confluent hypergeometric function. No problem. There are books on hypergeometric functions. You can see Slatter's book is there. Also the Mattei and Saxena in 1973. Slatter in 1966. And Mattei and Saxena in 1973 book is a very interesting book. Mattei and Hubbard 2008 book is also a very useful book for the practical, those who are interested in these functions and application for the practical situations. This hyperpoisson distribution, once we have the probability mass function, we can think of the probability generating function. It looks like this, G1t. Here, clearly, when lambda equal to 1, this hyperpoisson distribution reduces to the Poisson distribution. We look here, gamma lambda is gamma 1 is 1. Gamma lambda plus x, that is x plus 1 Gamma x plus 1 means x factorial. So theta raised to x by x factorial. The phi 1 lambda theta is nothing but e raised to minus lambda. So that because e raised to minus theta, because lambda is 1. When one this here 1 and here 1, it reduces to e raised to minus theta, e raised to theta. So e raised to minus theta, theta raised to x by x factorial. This becomes e raised to theta. And this is theta raised to x, this is x factor. This becomes x factor when lambda equal to 1. Now, like that, you can probability generating function also you can return. This becomes e raised to theta t. This is phi when lambda equal to 1, this becomes e raised to minus e raised to theta t. And this is e raised to theta. So e raised to theta into, so that it introduces to the probability generating function of the Poisson distribution. When lambda is a positive integer, and we can usually, when it is a positive integer, such a distribution is known in the literature as displaced Poisson distribution. And this distribution has been studied by staff in 1964. And Badwell and Crow termed this the distribution with lambda strictly less than 1. When lambda less than 1, such a distributions they termed as sub-Poisson distribution. And when lambda greater than 1, such distributions are termed in the literature by Badwell and Crow as super-Poisson distribution. Various methods of estimation of the parameters of this distribution were discussed in Badwell and Crow 1964, as well as Crow and Badwell in 1965. Also, the queuing theory associated with hyperpoisson arrivals have been studied by Nishida in 1962, and certain results connected with the moments on the speed estimation of the etc. also there in the Ahmed 1978. Ruhi and Ahmed 2003, there are two papers there. They studied the estimation of the parameters using the negative moments. And they also derived the expressions for ascending factorial moments and further obtained certain recurrence relations in that connection. And also Kemp in 2002 developed the Q analog of the hyperpoisson distribution. And Ahmed 2007 introduced the Conway-Maxwell hyperpoisson distribution. Several such works. Ahmed also obtained the bivariate version of the hyperpoisson distribution, also studied a bivariate version through the probability generating function of this form. And the probability mass function of such a bivariate form looks like this form. QRS equal to e raised to theta, gamma lambda 1, gamma lambda 2 by phi 1 theta 1, phi 2 theta 2, where phi 1 and phi 2, etc. Yeah, they are like this. I mentioned, here phi ix, that is phi 1, phi 2, like phi 1 lambda x, like that. So that this probability mass function contains these types of notation as a expression. And I'm not interested in the bivariate version. In fact, we have also developed the bivariate version of this distribution. Those results are available in the literature. I have not mentioned those results here in the present talk. Why? Because this talk is mainly targeting the postgraduate students. Their interest may be in the univariate case. So for the time being, I discuss about the certain other class of distributions. Those are related to hyperpoisson distribution. In fact, the alternative hyperpoisson distribution has relevance in this direction. It is quite difficult to, what is the problem here is, in case of the hyperpoisson distribution, I mentioned earlier, the professor, Badwell and Crow mentioned that it is sub-Poisson when lambda less than 1 and super-Poisson when lambda greater than 1. That's all. But it is not difficult. Why this distribution came into the existence? Mainly because the reason is the equidispersion, to overcome the equidispersion. So there are two types of dispersions. Then when it is not equidispersed, it is either over dispersed or under dispersed. So it is not difficult. It is difficult in case of hyperpoisson distribution to say whether it is when it is over dispersed and when it is under dispersed. because of these types of a functional representation of the confluent hypergeometric function involved in the mean and variance expressions for the mean and variance. So for the our interest here, whether there is any alternative models which is suitable for tackling this situation where such a argument, whether when it is over dispersed or under dispersed, depending on the parameter of the distribution. In that context, in one of our paper, which is published, I think during in Statistica, during 2012, I think so, I have mentioned it. We defined a alternative version of the hyper-Poisson distribution through the probability mass function like this. d2 of y equal to theta raised to y divided by lambda y. Lambda y is the Poisson symbol. Lambda into lambda plus 1 into etc. Lambda plus y minus 1. Phi 1 plus y, lambda plus y minus theta. What is the beauty of this result? Is mainly because, here also, when lambda equal to 1, this becomes e raised to minus theta. And when lambda equal to 1, this 1y becomes y factorial. So again, when lambda equal to 1, this distribution reduces to Poisson distribution. So it is again a generalization of the Poisson distribution. And please note that this alternative hyper-Poisson distribution, so probably we are writing the probability, think of probability generating function. Now, how to derive the probability generating function? This is our first task. My students, in fact, the graduate students, they can understand. In fact, what we do is, this is the definition of the probability generating function. Yes, G2T, that is summation y0 to infinity. That's it's a support is 0 to infinity. And this is the probability mass function G2y multiplied by t raised to y. So here G2y is theta raised to y by lambda y, phi 1 plus y, lambda plus y minus theta. And this expression, this is nothing but the confluent hypergeometric function. We can write the series form of the confluent hypergeometric function, so that this is equal to r 0 to infinity 1 plus y r lambda plus y r minus theta raised to r divided by r factorial. The other things are here, theta raised to y by lambda y, t raised to y already there. Now what we do is, here theta raised to y and this is here t raised to y can combine theta t raised to y, and this minus theta raised to r is there. R factorial is also there. Y factorial lambda y plus r. We can lambda plus y r divide by multiplied by lambda y. This can be written as lambda y plus r. You please note that this is a property of the Poisson symbol. When lambda y multiplied by lambda plus y r is nothing but lambda y plus r. So that is here, lambda y plus r. And 1 plus y r is y factorial raised to minus 1 into 1 y plus r factorial, or y plus r divided by y factorial. So I put here y plus r factorial here, y factorial here. Now G2T reduces to this form, where because we have this is a infinite series 0 to infinity, 0 to infinity. Now we can change the variable. The y can change to, so that y minus r, y changes to y minus r. So theta t raised to y becomes theta t raised to y minus r, so that this summation becomes finite as a consequence of the results of the infinite series, bivariate infinite series. So that y0 to r, r0 to y, minus theta raised to r, theta t raised to y minus r, y factorial divided by r factorial is already there. Y minus r comes there. and so that lambda y is already there, lambda y is there, so lambda y plus r, so that this becomes because y plus r means y minus r plus r is y, that is why lambda y, not already lambda y minus r plus r comes to, and so that this expression reduces to this series. You can written summation r0 to y, r0 to y, la theta t raised to y minus r, y factorial, minus theta raised to r, so that theta t minus theta the whole raised to y. It's a binomial expansion. So you can, what you have to do is you put a y factorial here, so that that's y factorial, y minus r factorial here, y factorial is already here, r factorial is here, so that becomes ycr. So ycr theta t minus theta the whole raised to y, or theta into t minus 1 the whole raised to y, and lambda y is already there. So what we get, this is in the light of the binomial expansion of theta t minus 1 the whole raised to y, and 1y is nothing but y factorial. So we can put 1y here, and here a y factorial also put here, so that this is lambda y is here. So theta into t minus 1 raised to y. So this is, you can written in terms of the confluent hypergeometric function. That is theta phi of 1 lambda theta into t minus 1. So this is the probability generating function of the alternating Poisson distribution. What is the important, very interesting property with regard to this distribution is, this distribution, you please note that it's a moments, while you are writing the moments of the distribution, that does not involve the confluent hypergeometric series. So here the factorial moments, rth factorial moment, mu r is rth factorial moment, in the sense that expectation x into x minus 1 into x minus 2 into etc. x minus r plus 1. That is expectation x into x minus 1 into etc. x minus r plus 1. That expression can be written as r factorial into theta raised to r by lambda r. Okay, now you can find the moments from this factorial moment relation, because moments and raw moments and factorial moments are uniquely determined by the certain relationships. So it is not a difficult thing. You can, for the time being, let me to consider what happens when r equal to 1. Then mu1 means expectation of x. So first factorial moment, first raw moment are same. So expectation of x means mu, in our notation you can or your usual standard notations is mu1 dash, no problem. That is equal to mu1, that is equal to r factorial means 1 factorial is 1, theta raised to 1 by lambda 1. Lambda 1 means lambda into lambda. What is lambda r? Lambda into lambda plus 1 into etc. lambda plus r minus 1. Then r equal to 1, that 1 cancelled out, it becomes that simply lambda. So mean of this distribution is nothing but theta by lambda. So mean is theta by lambda. Similarly, you can find the second moment, mu2. Mu2 here, mu2, when r equal to 2, this is expectation x into x minus 1. That is the second factorial moment. That is equal to 2 factorial means 2 theta square by lambda 2. Lambda 2 means lambda into lambda plus 1. That's all. Lambda 1 is simply lambda. Lambda 2 is lambda into lambda plus 1. So this becomes 2 theta square divided by lambda into lambda plus 1. Now you have mu2 dash, or you can find mu2 dash, because you have mu2, the second factorial moment you have. From that, that is expectation x into x minus 1, means expectation x square minus expectation of x. So that expectation x square, that is the second moment, second raw moment, equal to mu2 dash, this mu2, the second factorial moment, plus first moment, raw moment or factorial moment, because they are same. So that 2 theta square divided by lambda into lambda plus 1 plus theta by lambda. is the second factorial row moment, second row moment. Once you have the first row moment and second row moment, it is easy for you to find the variance. So variance of x becomes the second mu2 dash minus mu1 dash square. mu1 dash square means theta square by lambda square. You simplify the things. You can simply write, take paper and just simplify, so that you can find the variance. And variance, you get it as an expression like this. So mean equal to theta by lambda, and variance equal to theta by lambda times 1 plus theta by lambda into lambda minus 1 divided by lambda plus 1. Now, what is, you please note that when lambda equal to 1, what happens? This becomes 0. So that variance becomes theta by lambda, because lambda is 1, so theta. Mean becomes theta, so they are equal, so the equidispersion or Poisson distribution. When lambda less than 1, what happens? When lambda less than 1, the mean becomes larger. So mean becomes the variance, here the minus sign comes. So mean minus variance, you get a negative number. So that mean becomes, mean is greater than variance. Mean greater than variance means there is under dispersed. So the distribution is under dispersed when lambda less than 1. On the other hand, distribution is over dispersed when lambda greater than 1. This is a very interesting property of the alternative hyperpoisson distribution. So here the alternative hyperpoisson distribution, as a consequence of the earlier this result, we can found that the distribution is under dispersed when lambda less than 1, and when it is over dispersed when lambda greater than 1. Now to find the row moments, you can find there are, I already mentioned there, connecting relations are there. Even then you can find out, it is easy to obtain relations which are in terms of the Stirling numbers of second kind. This SNR is the Stirling numbers of second kind. So mu n equal to, there's the nth row moment can be found in this way. And the row moment is summation r 0 to n theta raised to r, where r is 0 to n. So r theta raised to r by r factorial, r into r theta raised to r into r factorial divided by lambda r SNR. SNR is the Stirling numbers of second kind. You can find the Riordan's book. There is a lot of things with respect to the Stirling numbers. I'm not going into those details for the time being. Now let us found the how to what about the estimation of the parameters of this distribution. I think now this time 3:43. So my time is up to 4. So it is not good to elaborate the estimation part. I think so. So with your permission, I shall give the those things in a skeleton. All of you know the method of moments. Similarly, it is possible one can estimate the method of mixed moments. In method of moments, we equate the sample moments and population moments. Here in method of mixed moments, we use the similar procedure, but one of the moment equation can be replaced by, we can usually you can take lower order moments where they are simple. So one of the equation we can replace by the probability expression. So the 0th level self frequency we can probability we can equate. That is this P0. P0 is this like this. N into phi inverse phi 1 lambda minus theta, that equate with P0. P0 is the observed frequency of the distribution corresponding to the observation 0. And the capital N is your total frequency, total observed frequency. So that you can estimate you can consider it as one of the equation. And first moment equate with the first sample moment, so that you have another equation. For this distribution is very simple because it has only 2 parameters. You can you can solve these 2 equations. Because these equations are non-linear, it is not easy to solve. we can use the computers. Nowadays, computers are held, or packages are there, softwares are there, MathCAD, Mathematica, MATLAB, etc. Or you can use your R program. You can write simple programs to solve these equations, or Python program. When you are thinking of the data analytic point of view, you can utilize such things also there. So that you can find the parameters mu, lambda, and theta, and thereby you can test the testing also can be done. So here we have attempted the mixed moment method as well as the maximum likelihood estimation procedure. In maximum likelihood estimation, you consider the likelihood function, then the log likelihood function, thereby differentiating the log likelihood function and equate to 0, and thereby differentiating the log likelihood function with respect to the parameters and equating to 0. You get two likelihood equations, and solving these equations, you can determine the parameters of the distribution, or you can estimate the parameters of the distribution. So estimation part is not much difficult. Anyone can do. I have given some examples where the estimation we have attempted. Yeah, another example. I'm not going to the details because of the time short. Here also the parameters are estimated first of all, and obtain the frequencies, expected frequencies, thereby obtain the chi-square value for testing whether fit is good or not, and found that the alternative high proportional distribution fits this data well compared with the high proportional distribution. So here Poisson is not suitable. We can think of high proportion, but even high proportion is not suitable, so that alternative high proportion is best, gives the best fit, in both level of estimation, method of mixed moments and method of maximal likelihood. Anyway, you can think of the testing of the hypothesis with respect to this parameter lambda. When lambda equal to 1, this distribution reduces to Poisson. Whether we have to check whether lambda not equal to 1 is reasonable. So that you can think of lambda not equal to 1, equal to 1 against lambda not equal to 1. And the test also here gives that the computed values of the test statistic. Based on that value, we compared with the critical value, this a tabled value at 1 degree of freedom, and found that lambda equal to 1 is rejected, so that for this particular data sets, the model alternative high proportional distribution is more suitable. Please note that here we consider alternative high proportional distribution. What we mentioned earlier, it is under dispersed when lambda less than 1 and over dispersed when lambda greater than 1, whereas it is difficult for us to discuss about the hyperpoisson with regard to this type of parameter. In that case, only we can say subpoisson or superpoisson. Those need not be under dispersed or over dispersed in that sense. But what is another idea of the important thing is, we have a generalized form of Poisson as hyperpoisson. It's a bad way to go. Another generalized form is alternative hyperpoisson of our family. And what about in certain data sets, which is better? Whether I have mentioned 2 data sets for which alternative hyperpoisson is better. In some other cases, hyperpoisson may be better. Yeah. So that what about these families? We have generalized further, and both combined both we come into the same umbrella. So we have developed a new class, namely alpha generalized Poisson distribution, for which both the hyperpoisson family and alternative hyperpoisson family are special cases. This is the situation here. So this is alternative or alpha generalized hyperpoisson distribution. Alpha generalized hyperpoisson distribution has probability mass function of a form G3 set. Not going to details. So G3 set. I'm not reading this. So when lambda equal to 1, this reduces to Poisson. And when alpha equal to 0, this distribution reduces to hyperpoisson. Whereas when alpha equal to minus theta, this distribution reduces to the alternative hyperpoisson distribution. In this case also, it is possible for us to obtain probability generating function. I have developed the derivation of the probability generating function here for explaining, but due to time short, I will not go into the details of that derivation. I think we obtain certain recurrence relation. Here, the probability mass function looks slightly complicated form. So we obtained certain recurrence relations for probability mass function, so that the probabilities of the distribution and these relations helps us to compute the probabilities, and also certain recurrence relations obtained, or certain, this is an expression for the rth row moment, which helps us to derive the moments of the distribution, in which this f1 is a function, in fact, the confluent hypergeometric function in two variables. Instead of there earlier the one variable, here it is two variable, here alpha and theta. And this is again Stirling numbers of second kind, SRK is there. And mean and variance you can obtain as delta 11 theta by capital lambda, and also the theta, here delta 11 and delta 12 are terms in terms of the confluent hypergeometric functions. Because here it is hyperpoisson is there, it is difficult for us to exclude such terms, but they will reduce whenever it reduces alternative hyperpoisson distribution, no problem. And mean recurrence relation for row moments of the distribution is developed. We can see through this result. And in case of factorial moments, it is simple, relatively simple. Once you know the lower order factorial moments, it is possible for you to find the higher order factorial moments simply by the product of this term multiplied by the lower order factorial moment. And here also we attempted the estimation, and estimation of the parameters of the distribution. Also the through both methods, method of mixed moments and method of maximum likelihood. Thereby, these are the likelihood equations, and solving these likelihood equations, one can obtain the estimators or estimates of the parameters. And here we compared hyperpoisson, alternative hyperpoisson, etc. With respect to the alpha generalized hyperpoisson. And also we attempted the testing. In fact, while consider data set, here the alpha generalized hyperpoisson distribution gives better fit compared to the other distribution. Here also, they are obtained. Another data set. In both, in all these data sets, alternative hyperpoisson alpha generalized hyperpoisson distribution gives a better fit, so that it can be considered as a more generalized family. And surely it is not difficult for one to evaluate derive the estimators or estimates of the parameters with utilizing the computer softwares like mathematical softwares like MathCAD, MATLAB, Mathematica, etc. Or you can use the programming languages or programming. We are not going to the details for the time being. And also it is possible for you to test the parameter lambda equal to 1 against lambda not equal to 1, and alpha equal to alpha also you can test. So both sides you can test. Alpha equal to 0 against alpha not equal to 0, so that the significance of the parameter alpha, that also you can done through this procedure. Now, I think we have only 5 minutes, and 5 minutes. In fact, you need to have questions. But sorry, I can take some more minutes, 1 or 2 minutes for the questions. I hope I can introduce the class of alpha generalized hyperpoisson distribution order K. Here we consider a K-point distribution with a PDF like this, and there is some parametric restrictions imposed, and thereby consider a sequence Wn as the sequence of independent and identically distributed K-point random variables. And the random variable capital N assumed to be the alpha generalized hyperpoisson distribution. Capital Z. And they are statistically independent, we assume. Suppose that they are independent. Thereby, it is possible for you to obtain the probability generating function of SZ. SZ is the summation N0 to Z. Yeah. Hello? Hello?
So you can continue.
Okay. 2-3 minutes, within 2-3 minutes, I shall conclude. Okay.
Yes, sir. Yes, sir. Okay.
Maximum 5 minutes. Okay.
Okay.
I hope I'm not going to detail. So this is a random sum structure, so that such distributions have relevance in several areas, several applications also. So that this probability generating function looks like this form: phi 1 lambda alpha plus summation j1 to k theta j raised to j, where capital lambda when is phi 1 lambda alpha plus theta, where theta is summation theta j. And this distribution contains the Poisson distribution of order K. Poisson distribution of order K is also very well-known family, studied by Filippo et al. 1983, also studied by myself and some others, and my professor long back, in fact, and also the stuttering Poisson. And here we also need a stuttering hyperpoisson. We call it as stuttering hyperpoisson distribution is also a member of this family. So Poisson distribution of order K is a member of family. Stuttering hyperpoisson distribution is a member of this family. Stuttering alternative hyperpoisson distribution is, or alternative hyperpoisson distribution of order K is again a member of this family. And several results you can see from these articles of myself and Nair and Patel, myself and Mutha, and several others, JSTP, Upsearch, etc. And it's a probability generating function we mentioned, and now it's a probability mass function looks like this form. And PM of is F3 Z lambda star, and here S is some notational difficulty you feel, but you don't bother about that. We have obtained the recurrence relations for probabilities. Mean and mean variance, etc. are like this. Here also we obtained the condition for the dispersion. It is over dispersed when this condition satisfied, and under dispersed if otherwise. So that provided this type of an inequality also holds good. And the probability recurrence relation I mentioned earlier will help us to derive or compute the probabilities of the distribution. And the moment recurrence relation or expression for moments also there. This is a moment recurrence relation which helps us to derive or compute the moments of the distribution. And factorial moment recurrence relation for factorial moments is also there. And the estimation. We have utilized the methods of maximum likelihood, also method of mixed moments, etc. for estimating the parameters of the distribution. I'm not going to the details due to the short of time, and thereby fitted the data sets and combined with stuttering hyperpoisson, stuttering alternative hyperpoisson distribution of order K for different values of K, and thereby alpha hyperpoisson distribution. Thereby you have considered several data sets, and Also testing of the parameters, alpha equal to 0 against alpha not equal to 0, and alpha equal to minus of theta, etc. Alpha not equal to minus of theta 1, theta plus theta 3. And thereby found that these data sets, for these data sets, the alternative hyperpoisson distribution or alpha generalized hyperpoisson distribution of order k where k here we found that k equal to 3 is gives a best fit, because here 1.22 is the chi-square value, whereas for other things 33.2, 23 etc. So that comparatively to the other classes, this family gives a better fit. And I'm come to the please note some of the references in this regard. Yeah, several references. I hope if you have any problem or any doubt or any clarifications, or if you need any reference, you please contact me. My email ID is with the yeah, here I have mentioned somewhere. Yeah, some I think. Yeah. Okay. You simply csk@keralauniversity.ac.in. You can use that mail ID. csk@keralauniversity.ac.in. I shall help you wherever needed. Waiting for your responses or your comments or your doubts, anything if there is time. Now I hope that it is 4:01, so I concluded in right time.
Yes, okay. Thank you, sir. Thank you, sir. Now the meeting is open for sharing. Dear participants, if you have any queries, you may ask now.
Okay, nowadays, in fact, there are email contacts and mobiles also there.
Yes,
so if they are not ready to ask questions, do not waste time for the next speaker. I think
yes.
so.
Okay, sir. Okay, sir.
Sir Joseph here. If you need to talk a bit more, you can take, because I will not take much time. So another 10 minutes. 10 minutes. Because people will be interested to listen to you.
Yes.
So you could start a bit late also. So there won't be any problem. If you want to talk, you can.
Yeah, in fact, I'm thankful to you, Professor, for your kindness. And since I have concluded, it's better not to come back. Go back.
Okay.
Better. If anyone has doubt, we can discuss.
Yes. Hope there is no more queries. So now I call upon Ms. Gigi MB, Assistant Professor, Christ College Autonomous, Irinjalakuda, to deliver vote of thanks. Over to you, ma'am.
Good evening all. On the behalf of Christ College Autonomous Irinjalakuda and Department of Statistics and everyone who is gathered in this online platform, it's my privilege to propose a vote of thanks on this occasion. My heart fills with lot of gratitude and respect for our distinguished guest speaker, Dr. C. Satheeshkumar, for not only sparing their valuable time for us, but also for enlightening time with your talk on the topic on hyperpoisson distribution, such as alternative hyperpoisson distribution and alpha generalized hyperpoisson distribution. Once again, I would like to express my humble thanks to Dr. C. Satheeshkumar for taking out time from their busy schedule and enlightening us with the knowledge. Thank you so much, sir.
Yeah, thank you, Dr. Gigi. Yeah, thank you so much for your nice words. Thank you, Devi sir, especially.
Thank you, sir. Thank you very much for your kind.
My prayers are always with you for your energetic, active, even though you are not retiring. It's
thank you, sir.
honoring the. I utilize this occasion to honor you, Professor. That is why I joined, and in fact, taken advice to some speakers also to join.
Okay, thank you, sir. Thank you very much.
Thank you so much. Yeah, thank you.
Thank you, sir.
Okay. Also, sister, please.
Okay, sir. Thank you, Satheesh, sir.
Okay.
So I have both sister and brother there.
Yes, once again, thank you, sir. Moving on to our last section of the day, I invite Ms. Sridevi PN, Assistant Professor, Christ College Autonomous, Irinjalakuda, to introduce the speaker. Over to you, ma'am.
Okay, thank you, Miss. Good afternoon, all. Today, I would like to introduce our last speaker of the day, Mr. Joseph ISS, Director, Department of Higher Education, Ministry of Education, Government of India. He was alumnus of Christ College, Irinjalakuda. He completed MSc in Statistics from St. Thomas College, Pale, and briefly worked as a guest lecturer in the Department of Statistics, St. John's College, Agra. He joined Indian Statistical Service in 2001 and worked in various offices of Ministry of Statistics and Program Implementations, Department of Commerce and Industry, Department of Tribal Affairs. Today, he would like to opportunities and second chances in life in conversation with an old student of Christ College, Irinjalakuda. On behalf of the department, I invite Joseph sir to deliver the talk. Welcome you, sir.
Thank you, ma'am. Thank you for introducing me. Before starting this session, I would like to offer my apologies to the participants. Okay, you don't have to open this slides right now. Why I am program as a tribute to our dearest Davis Anthony sir. I somehow took it as a program where only students of Christ College will be attending. A sister asked me to take a session, and we used to come. I mean, every year during Christmas vacation, we used to come to the college. And at times that whenever sir is there and students are there, they used to call me to talk with them. So I thought it is something like that. So I didn't think much about it. So I planned something informal, and I thought I will be talking with some students who are in an institutions where I attended some 22 years before. So it's like talking to youngsters who were not even born when I was studying over there, something like a big brother kind of stuff. But when I received this brochure, actually from one of my colleagues, first, all my impressions got shattered. So I never expected that it will be such a grand technical program where I will be asked to talk. And the topic which I will be doing will not be going with the general mood of this program, and a bit ridiculous for that matter. And I'm a bit embarrassed also. And some of the speakers, two of them are my teachers, KK George sir and Sebastian George sir. And Vinu is a very close friend, and Jayagumar sir is also a friend. So, and they are very good at what they are doing, and it's a pleasure sharing that an event along with them, but it's a bit embarrassing too, because what I was talking is not with anything related to the recent advancement in statistics and all. But somehow there was no time for rectifying the mistakes. I could have talked to something which is coming up in official statistics, but there was no time for that. So I thought of rephrasing what I plan to tell here. So initially I had a plan, something like a small data approach, talking about a particular incident from there to generalize and stress upon the point which I want to talk, especially when I thought about those second chances and all. But now I decided against that. So what I now do is I'll be showing you some statistics. Okay, some basic statistics, nothing that are recent or advanced. I'm talking about some averages, some figures which I come across as part of my job when I was deciding some large-scale sample surveys in NSS, and now being in a department of higher education, and showing you those figures and putting them in perspective. And on the basis of that, I thought I will discuss what I want to discuss. Okay, so I know that that yesterday when I joined that WhatsApp group, I came to know that some international participants are also registered with this. So I'll be talking in a purely Indian context, and so bear with me. And the second thing is that I'll be talking to the students. Okay, so that the rest of them also have to bear with me if they decide to stay. So, ma'am, you can show the first slide. Yeah, it's a silly joke. Maybe I might have read it when I was in Christ. It's this knock knock, who is there? Opportunity can be. Why? Opportunity knocks only once. 20 years before I read this, somehow it stayed with me even after these many years. Okay, we'll come to this at the end. Next. Yeah, right now I'm in Department of Higher Education. I'm the director of AISHE, All India Survey on Higher Education. So this is not exactly a survey, it's a kind of census which we do, where all the that higher educational institutions in India is mandated to give some returns. So every institution will have a nodal officer, and I know that in Christ, Robinson sir is the nodal officer, IJ nodal officer. So they fill up some data capturing format and send to us. And some higher education related statistics is generated out of that. And this is one figure I wanted to discuss. That estimate is the gross enrollment ratio. It is nothing but the total enrollment in higher education in the numerator, and denominator is the official age group for higher education, and 18 to 23 is the official age group we are having, and internationally it is 18 to 22 years. Why I am showing this? You can click, ma'am. Next. Yeah. So this is what I want to say. Only about 1/4 of youths in India are attending higher education. In other words, what I mean to say is that we belong to a privileged group. So I'm talking to that privileged set of people. So we can look at it that another way, that 1/4 of the population, 1/4 of that roughly 1/4 of that youth are able to attend higher education, any type of higher education for that matter. I'm not talking about a university degree or post-graduation, but it can be diplomas and certificate courses, everything together. Okay. And I was talking about 18 to 23 population. And what is the status when we talk about the entire population? Recently, there was a national sample survey on social consumption on education, which says that out of the total population with age group of 15 years and above, only 10.6% have a university degree. Okay. And when we talk about women, it is 8.3, even less than the total all India average. And when we talk about rural, it is very much less than the urban. So we are narrowing down, and I told you in the beginning that we are a privileged group. Now I want to stress that we belong to an elite group. Okay, next, ma'am. So I talked about the 10.6% who have a university degree or above, like postgraduates like you, that many of you, and PhDs like some of you. What about the rest? So in the rest, 25% were not even literate, and nearly 19% are just literate with some primary education. And another 16% could complete upper primary, and another 16% could complete secondary, and another 12% could complete higher secondary, which implies that those who are eligible to do higher education in India were only 23%. So we belong to that 23% of people. Okay, next. So what about that 77, I think, correct, percent of people? Why they were not in education? Why they are not in higher education? That I don't know whether you are aware about the statistics. And right now, when you are aware about it, that you have any idea about the reasons. Can it be purely economical? Economic constraints? That same NSS report also gives some insight into the reasons for that. Next. So there was an age group 3 to 35 years. These are the people, either youth or the persons who are supposed to be in school or colleges. This question was asked about their enrollment status. I'm not talking about higher education here, okay? Any formal education. So among these age group, you can click next. Around 11% in male and 17% in female could never enroll in any formal education, not even pre-primary, not even class 1, like that. Forget about higher education. Next. So then the reason was asked, the survey asked the reasons. So only 14 to 15% could reported that the reason was financial constraints. And half the population reported some other reasons. Somehow the survey instrument could not pinpoint what that reason was. It was not prepared for reporting those kind of reasons. So we are not aware what that other reasons. But forget about that 50%. And there are many more startling facts in that. One is this, the last point which this slide has. About 12% of girls could not enroll as they were engaged in domestic activities. They were making food and cleaning house, and so they couldn't go to school. Okay. And there were another 5% could not, as there was tradition in their community of going to education. Funnily, this 5%, when it say that there was no tradition in the community for sending kids to schools, that was 5% for girls, but it was only 2% for male boys. That is, there was communities where there is no tradition of sending girls to school. And for boys they are also not better. That many of them could not go to school as they were engaged in economic activities even from very young age. And a significant that portion in that reported that they were not interested, just not interested. That's why they were not attending. That is also very startling. Next, ma'am. So I was that somehow this that a topic I titled something with opportunity. So what I talk about when I talk about opportunity. So I was never planning to talk about what are the career opportunities when a person who is studying statistics or a person who is studying in a college or university has. I just want to make this statement. The biggest opportunity each of us had or having is the chance to be part of this privileged minority that had the luxury to attend a college or university. So I was talking about this opportunity. And we all know with great privilege comes great responsibility. So we have a responsibility to leverage the best out of that opportunity. It's not the kind of responsibility, okay, that which we used to think. I will come to that. And the responsibilities for our sake and also for the lesser fortunate majority, the other half who never had this opportunity, not because of their faults. And why we are attending is, I don't think that all of us are attending because of something which we did better, no. But I told that with this privilege, we have some responsibility. How? So before coming to that, I want to discuss 2 points that without which no discussion in education won't be complete. One is the Sustainable Development Goals, where in the global context, where it is mainly some 17 development goals adopted by the UN General Assembly in 2015 for transforming the world. And SDG 4 was on quality education. And India as a member country is a signatory to that. And we are also monitoring that different goals and the targets under them closely so that those goals are achieved by 2030. And the SDG 4 says that, exact statement, it is a quote from UN document. It is to ensure inclusive and equitable quality education and promote lifelong learning opportunities for all. So this is the goal. And under this goal, there are some 10 targets that how to achieve this goal. So at different level, different sectors, there are targets are fixed. And all these targets are getting monitored and state-wise, district-wise. So there are a lot of activities are going on. I don't want to go into the details of that. I just want to imprint this statement. 3 words, that is inclusive, equitable, quality education, and lifelong learning opportunities. Lifelong learning opportunities. Keep these in mind. And there is the last sentence is also important for all. So we are talking about the rest of the 75% of people also, or 77% of people also. Next, ma'am. Another thing is purely Indian context. Recently, we have a national education policy which proposes the revision and revamping. I just quoted revision and revamping of all aspects of education structure, including its regulation and governance, to create a new system that is aligned with aspirational goals of 22nd century education, including SDG 4. So this is what globally, what standards are fixed for quality education to transform the world. This National Education Policy 2020 is supposed to have that objective also. It is aligned with that. I'm not going to the details of NEP also. I don't even have the expertise to do that. Why I use this is to lift out some definition of a good institutions which was given in NEP. Next, ma'am. Yeah. This I lifted from National Education Policy document. A good institution, good educational institution. So each of these points are important. A good educational institution is one in which every student feels welcomed and cared to, where a safe and stimulating learning environment exists, where a wide range of learning experiences are offered, and where good physical infrastructure and appropriate resources conducive to learning are available to all students. So I studied in 3 institutions in my life. So one was Christ. So when I think about my college or especially my colleges and my schools, these questions used to come. So when we come to a college, where there are a lot of different type of students and teachers and different kind of atmosphere. Both the institutions I studied, or all the 3 institutions I studied, I could get a space as my own. So that first point, that everywhere I felt that I felt welcomed and cared to. Okay, so that yesterday only I found this in NEP, though we used to read it now and then. It was a very good definition of an educational institution. Okay, so I'll go to the point which I plan to discuss next. Next, ma'am. So the question is whether somebody can build such an institution, just like we construct building, adding up all the infrastructure, filling up library with all possible books, appointing teachers who are best in the field. These are part of the process, of course, but these are not alone. The main and the integral part is, next, ma'am, it's you, the students. And it is through that very much creative interferences you do in the campus, the give and take you do with your teachers, other students, and the society at large. You can create and sustain such an institution. How we do that? Then the question comes that why do we come to a college or an educational institution? Next, ma'am. Next. So these are the things. So I'm not coming to a college or university just to cram for exams. I do cram for exams, but I'm not coming there to just cram for exams. And your teachers are not sources to gather information. Yeah, your smartphones are better for that. We go there to learn how to learn and engage with the other aspects of learning that make or stay richer and worth. So this NEP also stress on the institutions. The higher education institution should not be institutions exist just to give degrees or just to teach for exams, and universities just to award degrees. No, they also should teach us how to learn. Okay, so this is what is supposed to do. I don't know whether we that actually think about in these lines, but we actually do this. We never come to cram. There are a lot of cramming centers to do that. They do better than a college. So even then, why do we take this pain and come to the school? I am just making it in words that it's that you all are aware about this. Next, ma'am. Previous one. Previous one I am talking about. Yeah, next one. So this is what this is one quote from my one of my teachers, and most of the people who studies in Christ College must be knowing about him. He was our department head, Professor M.P. Simon. He was a very dear teacher to all of us, a great teacher and a great human being, and used to talk a lot about a very good maths teacher, and used to talk a lot about many other things in the class, even when he's teaching maths. So we used to have very interesting discussions in class. So we are at times we used to argue. Then one day he was talking about education. So even forget the full form in that expansion of a plus b whole square. You might forget all the poems you mugged up, all the formulas you by hearted, all the equations, all the theorems, all the proofs you thought, which was very important while you were learning. You might forget everything. And even after many years, what remained in you after forgetting all this, that is the education you had. That is what Sir told. So I still remember that after 22 years, because I have forgotten what I have studied for my exams. So that what remained in me now, however less, I understand that that is what I learned. So this is what I also want to tell that my point was that one point which I missed was that about opportunities and when comes responsibilities. It is that doing this kind of give and takes, creating or making an institution which is built by someone or created by someone great with our creative interferences is the best thing which we can do to the society. And see, I'm just talking after 22 years. I am ignoring all the seniors who are here. Some of them are my seniors from college also. I'm just talking to the students over here. So someone coming back after 22 years. So this is what we can do over here. And next. I just wanted to initially I wanted to start with second chances because of some particular incidences, but I just to conclude that keep it in this one particular slide. This may not be important for you because you are all very young and will be staring at your first chances in life. So I would like to forget what I say now, and you can remember it at some point of time in future when you think that you blew up your first chance. I want to say is that there will be second chances in life, third and fourth for that matter. Okay, so I have taken those that many people I know, many people I adore have taken those additional chances in their life. Only thing to remember is that if you miss out your chance and wait for them, don't leave the quote before that. And one more slide. Yeah, opportunities knocks not only once but many times. Okay, so the first slide was a silly joke. Thank you. Thank you all. Hope that there is no question.
Thank you, sir. Hello.
Yeah.
Thank you, sir.
Yeah, thank you very much.
Now the meeting is open for sharing. Dear participants, if you have any queries, you may ask now. Dear participants.
No, Joseph.
Yeah, one more thing, sir. I wanted to tell this in the beginning that yesterday only this program was shared in our that batch WhatsApp group, and everyone was pulling my legs after that till now. And I want to convey our regards to you. So Davis sir was our class teacher in 2007. Sorry, 1997, and he is very dear to us. And I don't think that none of maybe Ravi Kumar will be here, but I don't think that others are here from our batch. But we have a plan to meet you sometime. I hope that you will continue in Christ itself for at least for some time. And today I'll be wishing all the best. I don't say that you are retiring. You will teach many more years, and we will meet over there in Christ itself. So I would like to take this opportunity to convey the best regards from all those around 40 people from that 95-98 batch, sir.
Joseph, a very good afternoon.
Thank you, sir. Good afternoon.
Thank you very much for the all batch of the second year BSc Mathematics. This year also, I waited for you on the Christmas during the Christmas vacation. I think last year and the year before last year also we met together, all with
Yes,
Ravi Kumar and all other batches. Anyway, I am very happy to know all of us you have in your mind. I am still alive, and convey my regards to all the batchmates. And
sure, sir.
Yeah. Then I am very happy to see you in this platform for sharing this information. Even though this is not purely a technical session with a lot of equations and all, I hope this will be a very eye-opener to the young generation, especially those who are very much privileged with that platform for education. I think you have also applied a lot of statistical techniques you studied in graduation and post-graduation level for that. In that level, I hope you can join with us in this discussion of academic discussion of this subject. Anyway, I have some very little queries about the topics you shared with us. First thing, I was the former nodal officer of IISHA in this Christ College when it started in 2010.
Okay.
Then 2010 to 2015, myself also was the person who uploaded all the data in DCF. But that time, this is today only I'm knowing that you are the person behind all these efforts, the director of the AISHA. I'm very happy to know that you are behind this AISHA in AISHA. And the other thing is, all of these institutions all over India is coming or enrolled in this platform of AISHA, or only that arts and sciences or
no sir, all such institutions, because now that you must be knowing about that national scholarship portal through which the students can apply for the government scholarships. So now it is mandatory that all the institute, that if somebody is applying for scholarship through national scholarship portal, that institution should have an AISHA registration code.
Yeah, right.
So now it is mandatory, and that all the IIMs, IITs, AIMS, and even standalone institutions like some paramedical institutions, all these are there. Around 65,000, 62,000 institutions are there till 2020.
Yeah, the students coming in School of Distance Education who are doing some.
Yeah, they also. Yeah, they are also
coming in.
Yeah.
So I think all these data will include all who do higher education in India.
Yes,
definitely.
Sir. Yes, sir.
So have you taken any remedies for streamlining the students coming to the higher education based upon the report you proposed?
Sir, that actually NEP also proposes mean that kept a target of 50% of enrollment by 2035. So I talked about 26.3, and the next round it is just about 27.1%. So it's a long way to 50% if you know that almost that half of the things are remaining. And programs are there, and maybe that we can capture a bit more that if we go about. But the fact remains that because of many reasons that higher education, a privileged set of people are coming. And since we are talking about this, even though I was not very much involved with that, I don't know whether you are aware, there is some platform called Swayam platform, which is developed by So I don't know about there are some reservation about the quality of the content which is available over there. But now that the UGC has issued a notification that there is a possible of credit transfer if you want to do a course from Swayam, especially as an elective paper or so. It is possible to transfer that credit of the online course into that student's account. So there is some notifications UGC has done and some provisions they have made in the UGC Act. And of course, the person who is handling this Swayam platform is my junior. So yesterday, when I was preparing for this one, so I was talking with them. So they are putting a lot of fund into that, and they are trying to get the best faculties from this technical institutes and all the reputed institutes to develop the courses. But it has its own problems. But that overnight, I was just repeating, overnight we cannot have a fully functional and without flow that system. So it is through the feedback that if there is an improvement, it can be done through the feedback. So even if it is not for transferring the credit, that I think that in our colleges we should be asking our students to do some courses in Swayam. And if there is a feedback platform for that ministry should get those feedbacks. And the second thing is that the Christ is an autonomous institute now, and Pala College recently got the highest grade in accreditation. And there is a scheme called Study in India. So where these foreign students are abroad, and some institutions which has either NIRF ranking up to 100 or 3.2 NAC score. So this is the condition. These institutions can apply for an institution to host students from foreign countries under Study in India program. So many of the colleges are doing. I know that Rajgiri is doing, and at times I think Nirmala was doing, and that till recently that once again one Malayali junior officer was in charge of that Study in India program. So that I feel that both St. Thomas College, Pala, and Christ College will come in that ambit of that necessary condition. So I remember when I was a student, we used to have some foreign students over there which comes through some other way. But I feel that we should make use of these opportunities also. And Christ College will be in a way to become a university in quite a recent future. So that this is the way that policy also plans colleges from their autonomous and autonomous colleges to university to give multidisciplinary subjects and all. And Christ and St. Thomas is already like that. So they have the capacity to be a university in the recent future also. So that should bring the growth, and we will be proud of being part of that.
So one more clarification is that you have any survey regarding the generation youth which are out of this 23% that not coming to the higher education?
Yeah, sir, our survey within the ministry, that in higher education we do institutional surveys. So our information which we get is from institutions. So the people who are not in institutions, we don't have data from that. But this can be obtained only through household surveys. So household surveys are a part of the statistics ministry, especially National Sample Survey, and they do conduct surveys. So that one main source is this social consumption on education, which they do every 5 years. So the last time it was 2017-18, and now they are having a yearly survey on multiple indicator surveys where education is also a part. So these reasons they check. Okay, so on that, whether there is any action, that is up to the states, because education is that always a state subject, and of course data is there, but not with Ministry of Education, but with NSS there are data.
Okay, Joseph, thank you very much for your valuable information.
Thank you, sir.
Thank you, sir. Any other queries? Any other queries? Hope there is no more queries. Now I call upon Ms. Lynette Mary, second year MSc Statistics student, Christ College Autonomous Irinjalakuda, to deliver vote of thanks. Over to you, Lynette.
Good afternoon to one and all, respected dignitaries, teachers, and all other participants. It is my privilege to thank Mr. Joseph CF for his enlightening talk on the topic opportunities and second chances in life. I'm pretty sure that the information you shared will really help us. Once again, thank you, sir, for reminding us that opportunities knock not only once, but many times. On behalf of Department of Statistics, I extend my gratitude to you, sir, for sparing your valuable time for us. Thank you, sir.
Thank you very much. I just saw, I thought that Joe sir left. Sir, happy to be in your class after 20 years. Joe sir, I am taking a couple of minutes.
Yes, sure,
Last time I met Joe sir sometime in 2010 or 11. I exactly don't remember, but when he was principal. I took my wife and kid to we went to Pala, and from there I went to college. So it was an off day, and that day sir was there in the office. So then somebody met me, saw me. Then he told that Joe sir is there in the office, and they took me to his office. Then that day we were talking, and out of a sudden sir was talking about that what mark I got in the exam in 2000, so 10 years before. So my wife was amazed that he still remember you. That is a big thing, and he still even remember the mark you got. So that is Joe sir, and I told you that it's not that his sister also must be knowing that she's his student, that Joe sir is someone who used to take a lot of care for his students, and we are all beneficiaries of that. And we had very small dreams in life, and he is the one who have that change those dreams into different fields. And I know that all his students will be vouched for that. And it is a great pleasure, sir. I feel that I don't embarrass you today. Be in the same platform, that is something like a privilege. And thank you, sir. Thank you very much.
Thank you, sir.
So thank you, Joseph. All best wishes.
Thank you, sir.
Thank you.
Now I kindly request all our participants to switch on your videos. Dear participants, kindly note there is some issues with our feedback form posted in chat box. We will rectify it as early as possible, and we will provide it through email and WhatsApp. Okay, once again, thank you all, and hope to see you all on 1st March 2021 at 2 p.m. Once again, thank you all.